Okay, so I guess we'll get going. Welcome, everybody. My name is Marcus. I'm the program scientist for the Tampa Bay Estuary program. This is actually our first Open Science Subcommittee meeting of the year. So I think I mentioned last time we met, it was November last year, that we're switching to biannual meetings, so twice a year now. I've achieved all my goals for open science in the last couple of years, so I'm just basically scaling back the meetings. Um, just kidding. We have a lot of meetings at the Estuary program, and so we're trying to kind of balance the inundation of information we give to you all. So that's kind of why we scaled back. But because we haven't met in a while, I'm going to force everybody to introduce themselves. Just say your name, where you're from, and that'll be it. And then we'll get rolling. So I'm gonna go from top left of my screen, and I'll just call out your name and just say who you are, where you're from. So first I have Greg.
Hi, this is Greg Blanchard with Manatee County Natural Resources Department. I'm the Air and Watershed Protection Manager.
All right, thanks. And we have Issa.
Issa Ali, Senior Scientist, Applied Sciences.
And we have Blake.
Everyone, Blake Simmons, environmental social scientist for the Tampa Bay Estuary program.
Then we have Lindsay.
Hi, my name is Lindsay. I'm a student researcher at the Geosciences School at USF.
Welcome. And we
Thanks.
have Gabrielle.
Hey folks, I'm a social scientist guest of Blake today, and I'm sitting in to hear what's going on at CBET.
Welcome to the group. Blake warned me you were coming, so I hope it's worthwhile. Next we have Ed.
Ed Sherwood, Director of the Tampa Bay Estuary program.
And Carrie.
Hi, Carrie Flaherty-Walia, Restoration Ecologist, Tampa Bay Estuary program.
And Julie.
Hi, Julie Christian with the Environmental Protection Commission of Hillsborough County.
Hey, Julie. Then Jennifer.
Hey, good morning, everybody. Jennifer Schaefer Consulting, calling in from Sarasota.
Morning, Jennifer. And we have Alex.
Hey, Alex Manos with Pinellas County Environmental Management.
Then we have John.
Hi, I'm John with the Florida Fish and Wildlife Research Initiative, Research Institute.
Got it. Then we have Carly.
Hey, Carly Jones, Science Communication Coordinator with TBEP.
And Emma.
Hi, I'm Adontis. I'm an environmental specialist with Pinellas County.
Hey, Emma. And then Mike.
Mike Wessel, Environmental Science Associates.
Good to see you, Mike. And then we have Dave.
Hi, I'm Dave Carlin, Environmental Protection Commission of Hillsborough County.
That's all I got on my screen. See, did I miss anybody? I see Maricela just jumped on. You want to introduce yourself, Maricela?
Hi, yeah, I'm Maricela Perryman from the San Juan Bay Estuary Partnership. Hi, everyone.
Welcome.
Thank you.
And if I didn't get you, please speak now or don't speak, your choice. I think I got everybody. All right. So as per usual, basically, I will provide some updates, open science updates that I think you all may or may not be interested in, but things that I think are useful to share with the group. Then we have two presentations. First one is going to be by Alex, talking about his experience with open science at Pinellas County. And then Blake, who will be talking about data visualization. And he actually gave this presentation to us internally a while ago, and I thought it would be good to share with you all. Another thing to note, too, is that Megan Schrant, who was the other co-chair for the Open Science Subcommittee, is no longer with us. She actually took a different position with the National Park Service down in the Everglades. So essentially, we now have a position open for co-chair. And I'll explain what that means and why that's relevant to you all. But before I do that, I always like to start every meeting with basically reminding you all what this group is about. If you've been attending this meeting for a while, you've heard this ad nauseum. But we kind of have three key roles and responsibilities or goals that we try to do as an open science subcommittee at the Estuary program. Obviously, we want to support the development of OS products at the Estuary program, as well as any tools or workflows or products that may be useful to you all in your daily jobs. We also try to identify priority research areas for developing open science products. I want to talk a little bit about that today in terms of indicator development at the end of the meeting. And we also do training activities. In the past, well, we've done our training. Last year, we did an open science general training that I know many of you all attended. And we have one coming up that I'll talk about in a second that I think will be interesting and useful to you all. So you can go to a link to this guiding document that explains all of this in a lot more detail. So definitely check that out if you haven't seen that before. So co-chair nominations. We kind of have a process for doing this, but this is a pretty informal group. So I kind of want you guys to lead the charge on this to see if there's interest among several of you all to be a co-chair. Essentially, I'm accepting nominations. I'm going to keep it open until June 12th. So basically, if you want to be a co-chair or you have someone you want to nominate as a co-chair, let me know. Send me an email with that individual's name or your name with your expressed interest in being a co-chair. The responsibilities for co-chair, I like to think it's pretty minimal, but this is kind of your opportunity to shape the direction of this subcommittee. There's actually a list of those responsibilities in the guiding document, but really what it comes down to is kind of running this meeting, helping me organize speakers for these meetings, and basically bringing any topics to the group that you think would be of interest to share with everybody. And once the nominations close, we will hold a poll. So basically that will just be an email to everybody on the Open Science Subcommittee email list. Assuming everybody that's on this call is on that list. If you're not on there, you can go to our website, tbep.org, and go to the page for our technical advisory committee. On that page, there's a sign up link under the Open Science Subcommittee of the TAC where you can enter your email address. But basically, you'll see that poll, and basically you'll click who you want to be the co-chair, and we will decide. Just to remind you as well, if you want to be a co-chair, open science is a lot of different things. I have historically brought in speakers that have talked about some of the technical components of the open science tools, some of the tools of the trade, if you will. That's kind of my interest, and I kind of think that that's in the infrastructure school of open science, but it is a lot of different things. It's not just the tools. It involves aspects of, how do you share data more openly, or elements of participatory science, or more equitable access to different parts of the scientific process. So if you have an interest in any of these things, you don't have to be an expert in any of it at all, but basically I'm showing you this because I want to cast a wide net to people that may or may not be interested in being a co-chair for this group. So yes, send me an email if you want to be nominated, or you have someone that you want to nominate, and we will send out that poll in about 2 weeks, and next meeting we'll have a new co-chair. Any questions about that? And if I don't get any nominations, I'm going to nominate people myself. So you've been warned. Okay. The other announcement I wanted to make, actually the second of a few, is that we are going to be holding a hackathon. And this falls in line with our goals for the group of facilitating training. As I said before, we've done our training and open science training in the past, and this hackathon is not really a training event, but it is an event that I'm hoping to bring individuals together to help us, the estuary program, sort of figure out some of the gaps that we have for reporting on various indicators of bay health. We have a lot of different indicators, as you know, water quality, habitat. If, we're working on some new ones now, like fecal indicator bacteria, climate change indicators, basically, anything that we care about as a program that informs us as well as our partners on, what is the status of different components of Tampa Bay. So this hackathon is going to be January 27th, the start of next year. We've booked the space at the Tampa River Center. It's already secured. So that's a signal to y'all that we are serious about this. We're going to do it. We've got the space reserved. And what we're hoping to do is bring together different groups that have an interest in working with us. So this is going to be a competitive event where basically the winner of the hackathon will join in contract with us for about a year or so. We have some funds set aside to help more fully develop this indicator product. And so it's going to be, I've never been to a hackathon, but it is kind of like an intense sort of event where you're scheming, you're developing your coding throughout the day. And the idea is that people will sign up in groups or self-select into groups the day of, and each group will focus on an indicator that we choose and develop kind of a workflow or a scheme or a set of data tools to develop a process for reporting on that indicator that then will be more fully developed throughout the year if they get selected to contract with us. So it's still a lot of the details for this. We're still working out in terms of the logistics, how the scoring is going to work for the competitive process. But look for a formal announcement for this hackathon later the end of summer and the fall, where we'll have a registration page where you can sign up as a group or individually, as well as some of the criteria for what we're hoping to get out of it. So I'm telling you all now, being the Open Science Subcommittee, just to, you guys are special to me, so you're getting an early warning into this. And so you can maybe start thinking about how you might want to approach this. But look for that formal announcement in the fall, and I'm very much looking forward to the event. And if it works well, we'll have more. So yeah, any questions about that? Any question hackathon? Has anyone been to one besides Blake? I know he's been to a few. Share your thoughts, experiences. Was it fun? Was it terrible? Anything we should do or should not do? I would love to hear your thoughts on that. Everyone's really excited. All right. Well, we'll get that info to you all soon enough. The third announcement I wanted to make was related to our CCMP. So every estuary program has a CCMP. This is our Comprehensive Conservation and Management Plan. It is more or less like a laundry list of items that we care about as a program for promoting the protection and restoration of Tampa Bay. So it involves things related to water quality, fisheries and wildlife, habitat. There's a large public outreach and community involvement component. But basically, it's like our guiding document as a program. So everything we do speaks to different components of this CCMP. And related to the hackathon, we have basically a suite of indicators for different parts of the CCMP, and there are components in there where we don't have good indicators. And so if you want to sort of understand what we do as a program and where we may have gaps in terms of indicators, look to our CCMP. But historically, our CCMP, it was drafted a long time ago and we updated about every 10 years. Right now, we're going through an interim update, which happens every 5 years or in between the larger updates. And what we're trying to do is really kind of bring the format of the CCMP into an open science format, basically. So the previous one, a very comprehensive document with a wealth of information, but it was essentially a PDF document that was difficult to navigate. And that's, we thought, kind of an impediment to the work that we do, because oftentimes we point our partners, our stakeholders to this document, but it's difficult to navigate. So we actually created this as a Quarto web page that is online. The source code is available on GitHub. And the idea here is that actually there's sort of two motivations for this. One, it's going to be more easily updatable. So because it's online, it's accessible. We can update this more easily when we have to do that larger update in the next 5 years and hence moving forward. And the second idea is just accessibility of this website that you see on the front end. And the idea here is that we want essentially 2 clicks of this website to get anywhere, to navigate all of the actions and the activities and the different priorities of our CCMP. So there's various navigational components. There's kind of 3 main themes. There's clean water and sediments. There's wildlife, there's informed, engaged, and responsible community. And under these 3 main priorities, there's various actions, and you can sort of navigate them from this list here. So this is showing you the public education action under the informed, engaged, and responsible communities priority. And so each one of these actions has, a narrative description of what it is, a background, and we're trying not to overwhelm you with text, so we sort of organized it hopefully in a nice accessible way. And there's obviously more text you can expand to. There's various activities associated with each action that kind of talks about who we might work with, where the funding is coming from to address these different activities, so on and so forth. At the bottom, each page, there's a footer that actually has some of this high-level information. You can look at a list of all actions together here, hyperlink to the individual actions, that sort of thing. So this lives on GitHub right now. We will have on our main web page, our tbep.org web page, a landing page for this Quarto website document that lives on GitHub, and then we'll have kind of like an interactive map that shows Tampa Bay and its watershed and links to the different actions that will point to different parts of the Quarto webpage. So we've spent a lot of time putting this together, trying to make it a lot more accessible. The source code is available on GitHub. Like we do encourage feedback on this, so you can get in touch with us and say we don't like this format, we like this format, or there's a typo. Or if you're GitHub savvy, you can actually go to the GitHub page and suggest an edit. We've talked about that many times in the past as a way to contribute to our living open documents. So it is still, I guess we're still considering this a draft product, but at this point we're unveiling it to you all and opening up for critique and suggestions. So have a look at that. Get in touch if you want, and then let us know how we're doing with this document. There it is in my slides. And then the last update, I want to make sure that our speakers have plenty of time. But the last thing I wanted to bring up is we have a new report card that was unveiled in the last couple of months that is adding to our encyclopedia of report cards that we have available. But this one speaks specifically to habitat restoration projects and the goals and targets for our habitat master plan. So we've actually added a new card on our website. If you're familiar with the data visualization page of tvep.org, there's a new card that if you click on it, it'll go to this. That will be like a high-level summary of this report card, telling you what it's all about, what we're trying to do with it, and then links to several other things like the source code behind it, other tools, some of the publications underlying the ideas behind this report card. But just to quickly show you what this project is, or what this report card is doing, we have basically a lot of partners that are pursuing numerous restoration projects every year. They report on those projects to us. We report on those to EPA, and we want to basically provide a synthesis of those reported projects to you in a nice digestible format. And so the first page of this project kind of talks about, what were the projects done in any given year. So we're going to produce this every year. So last year, 2023, this is a summary of what was done in our watershed. In January actually towards the end of this year, we'll do the 2024 project update, and you'll see an updated version of the report card that will show you the progress this year. And then the second side is really more about how we're doing as a program towards meeting different targets and goals for the Habitat Master Plan. And if you're not familiar with that document, that is a comprehensive document that lays out where we want to be for native habitats in the short term. So by 2030, there's targets for native habitat coverage for 2030, and then long term, in 2050, there's goals and coverage for those habitats. And the idea is that through all these restoration projects that we're reporting on in the first page, that will manifest up to noticeable gains in habitat coverage that we can track towards the goals and targets in our Habitat Master Plan. So you have a summary basically of how we're doing, how far we have to go, and then this, again, a stoplight graphic style report card that talks about, or that kind of shows, have we met the goal? Are we trending away from the goal or towards the goal? Have we not met the goal? And that sort of thing. So this is all really, an attempt to be more transparent with our partners, sort of conveying how well we're doing, where the priorities are towards attaining different targets and goals, and really kind of distilling it down into that nice sort of 2-page format, which is very similar to a lot of the other report cards we have. So yeah, check that out. Obviously, a lot of that is driven by other open source tools we have available. There's functionality in TBEP tools, our package, to create some of those graphics that go into that. It's also driven by a habitat restoration database that we stood up recently. This is also openly available online for anybody to download. It's citable, it's got full metadata documentation, but really this is, again, an effort to make these tools more understandable and accessible to the people that are actually doing this work in our watershed. So that's it from me. I want to give time to our speakers, but I also close with, links to things that I see throughout the course of time from when we last met to now that sort of describe things that may be of interest, new open science tools or trainings. I don't want to go through them now, but you can check them out after the meeting here. So any questions about any of that before I hand it over to Alex? Comments? All right, well, I will now hand it over to Alex. Stop sharing my screen. Alex, I made you a co-host, so I think you should be able to share.
All right. Can you see my screen?
Negative.
How about now?
All right, there we go. Yeah, so Alex will tell you all about this, but he's been working for Pinellas County for how long now, Alex?
A year and a half.
Year and a half, and he's done some really cool stuff with open science with them, and I invited him here to talk about his experience doing that. So take it away, Alex.
Yeah, thanks, Marcus. Yeah, like you said, been with the county for a year and a half. Most of my time there has been doing this type of automation. It's been really, really great for the past, year and a half to get to know the program so well and get to do all these, try and improve these efficiencies. So I'm excited to share that today. So I kind of just want to give you a brief overview of our sampling program for our water quality design and implementation. Don't want to get too much into the details of that, just kind of let you know about what we do, some of the different open science tools that I've used during my time there to automate the various processes of that program. And then get into some of the data products that I've been able to produce to get to share internally and public facing. And then I kind of just want to, let you know about what I think the future of open science at the county is, at least within our division, in terms of sharing data, different tools to use, and methods that we've used. Okay, so again, I don't want to get too much into the details, just kind of give you a brief overview. So our water quality monitoring program is divided into two parts. We have a fixed site sampling program. So you can see this figure on the left with the green dots. Those are freshwater and tidal stream sites. And then we have a stratified random sampling program, which includes lakes and coastal marine waters. So the figure on the right, you can see Lake Tarpon and Seminole, as well as all the coastal waters. Except for St. Petersburg, we do not sample there. So we have 8 sampling periods throughout the year, so we can get wet and dry season coverage. And then we have a pretty standard suite of water quality parameters, nutrients, chlorophyll, water clarity like TSS, turbidity, Secchi, bacteria. And then we do in situ, like dissolved oxygen, conductivity. So if you're not familiar with a stratified random sampling, it's also known as probabilistic sampling. It's basically where these hexagonal grids are overlaid on each one of these stratums. So we do that for each of our coastal waters and those lakes. And so sites are randomly selected within each grid. And then for our sampling, we do a further random selection of 4 points across the hexagons per sampling period, which ends up being 32 per year per stratum. And then we divide the stratum into morning and afternoon sampling to remove any temporal bias. And so both the sites that we sample and the dates that we go out and sampling for these strata are randomized. So for the stream sampling, those are in our ditches, canals, and the Inklet River. And so the sites that we have tidal influence, we have to actually go and look at the tide chart to see when there's a slack tide. So we try to do sampling as close to the slack tide as possible, or close to it. Just depends on the day that we can get out based on staff availability and holidays and other things like that. So, and then the actual locations of the sites are selected well in advance of sampling, and they're based on watershed coverage, so we can get as much of the sub-watersheds within Pinellas County as much as possible. Okay, so from high-level overview of our program, we get our sampling dates and locations about 4 or 5 months before the next calendar year. And then at the start of each sampling period, we request our sample bottle kits from our county utilities laboratory. And then we actually go out and do the sampling. At the end of the period, when we're done sampling, we compile all of our data from all of our data sources. And then we perform any QA, QC on the data and make any corrections that need to be done. And then from there, we can submit the data to DEP in their WIN format. And then we can also submit to our other data partners like USF for their Water Atlas page. And we can also do any other analyses we need to do, like trends and nutrient loadings. So my goal over the past year and a half has been to use, these open source, open science tools to automate as much of this whole process as possible, just to improve our efficiency. And so my favorite tool for that is R. I'm not going to get really into any code today. Maybe that'll be for another time, but all of the automation I've done has been based in R. So I'm just going to tell you some of the packages that I've used to get this process more efficient. Okay, so starting with the strata sampling. So what used to be done was that the strata would be selected in ArcGIS, and then there was we had this old legacy SAS code that was 20 years old and was divided into these multiple files and these steps. So you'd get ArcGIS file, put it into the first SAS file, and then into the next one, and the next one, and then you would get the actual location and dates of the sampling. The problem with this, though, is that SAS requires a license to use. So we only had one within our group, which obviously is, a problem if a bug, something comes up in the code and an issue. There's really limited staff knowledge of SAS, so it makes it difficult to to fix that in any way, which also reduces the transparency of that because only one person can really see that. But luckily, thanks to ChatGPT, which has been just a game changer, we've been able to put in the SAS code into ChatGPT and say, please convert this to R. And it does a pretty good job. It doesn't always get it right. Most of the time it doesn't get it right, but it at least gets the ball rolling so you can, so I've been able to kind of decipher the rest and get that old SAS code into a working R version of that. So the new way that we have it now is that we still use ArcGIS and get the sampling locations, and then take that old converted SAS code, have just a single R script, and from there it can just be easily run and generate those points and dates. And so that makes it so all staff can view the code and edit it and run it. And so we can have this in-house expertise develop around these functions. Even though ArcGIS requires a license, we still use it for other things within our group, so it's not a limiting factor. For the sampling dates, there was no previous automation with this. The tide charts would have to be inspected for each site, and each, had to pretty much just go through the dates one by one and see which dates had the best slack tide within a certain time range. But I've used this package, RTide, to basically pull in the tidal heights automatically. And I was able to write an algorithm that would select the optimal tide height. So find when a slack tide would occur between about 9 and 12 o'clock. So because that's usually when we go out sampling. So that would be the best time for that. And so I was able to combine that with the strata code that I talked about to generate this yearly sampling program, so that it's all just one streamlined process. We just run it once and it does all of it at the same time, instead of having these different different functions that do different things in different languages. It's all just all grouped together. So once we get our dates for sampling, we need to submit these sample bottle kit request forms and the chain of custody to the lab so that they can put these together. I did this one time by hand and realized I didn't want to do that by hand anymore. So it's not incredibly cumbersome, but it's tedious enough that it just took a long time. So basically, you have to fill these out in Excel, and then one by one submit them to the lab so that they could get all the runs together and all the bottle kits. But there's this package called RDCom Client that's really good for sending emails through Outlook. So the code I wrote basically just it's a function that you just put in when you want to pick up the bottles and your name, and it will fill all this out automatically, and then generate emails and send them to, in this case, send them to the lab, and it fills out, the subject, attaches the files, writes the body of the body of the email, even attaches a signature, and it just makes it's pretty much instantaneous. And then we go out and do our sampling, and at the end of the period, we compile all of our data sources and do the QA/QC. So these are the different sources of data that we have. We have the top there is a YSI meter that we use. That's for our in situ sampling. And then we have a survey 123 file. It's basically, when we went out, the time, observations, depths of sampling, samplers' names, things like that. And then we get our LIMS data from the lab, so all of our actual water quality data. So what we do is we have all these data sources and we put them into a HOC-WIM system, which is basically just a repository to store the data and do some reformatting. And from there, it can generate these Excel files that are the standard WIN reports that we submit to DEP. And so we need to do QA/QC on this. We can do QA/QC beforehand on the YSI and survey. We don't have access to LIMS before it's in HOC because of a firewall. But then we do QA/QC on the files that get generated by this HOC process. So previously, all the automation in this was limited to the HOC-WIM system. That's like the reformatting and going through and doing some checks. But all other QA/QC checks were done by hand. So checking times and dates, checking for missing data, doing matching between data sets and combining like the YSI and the survey 123. Those were done by hand, which, it's a very long and tedious process to do that. But the current process, the code that I've written basically does all those checks automatically. And I've used Quarto to generate these parameterized reports that give a list of all the checks that were done, check to see if missing data, and we'll give a report about what's missing and what needs to be fixed. There are still some things that can't be fixed by code, typos, and especially with missing data, some of that needs to be fixed by hand. But this just gives a much more ability for us to reproduce our QA/QC in a consistent manner each time. Because people can mess up, happens all the time, but this will do it the same each way. So it's just a much more transparent and open process to do it this way. And it provides a paper trail so that we can have all these documents over time. So at the end of each sampling period, we can save them. And if something comes up later down the road, we can say this error was caught and fixed, and so on. So the processing time before this automation, estimated 5 to 8 weeks. But we're hoping after this, it will be cut down to maybe 2 or 3 weeks. We haven't fully implemented this into our program yet. It's still kind of in the testing phase. So maybe this is a little optimistic, but yeah, I think just being able to cut down on the majority of, the number of people looking at it and handling it is going to cut down the time a significant amount. And so once we do that and can really quickly automate that QA/QC system, we can get that data out to our data partners much faster. USF has their Water Atlas dashboard, so we can provide that data to them much faster because there is a delay. So when people go and look on there, they're not seeing the most up-to-date data. It can take some time. And then we can submit that data to WIN a lot faster, so that they can catch any errors and we can correct it as soon as possible. And then we also submit our data to, local municipalities if they request it. And having this, this whole QA/QC process shortened can allow us to get that out to them much quicker and provide more up-to-date data. And one thing that I've been working on for the past a year, I guess it's already been, has been our own dashboard. So I've been using R Markdown and Shiny to generate this dashboard. This is the link for it. I guess it's open. There's still some things that still need to be fixed. So it's still in a draft phase, but you can, feel free to go to this, go to the link, check out the dashboard, provide, any feedback you might have on it. Right now, we still only have the free tier of this. So I think it's limited to 3 people at once. But, this has been something I've been working on for a while to just get our data out there to the public more. So this will be a public facing dashboard. So it's much easier for for the public to see the data and download it, and it's a little more streamlined than our Water Atlas page. So we're hoping that it will be just a little more convenient, so people can really view the data, especially in an easy and understandable way. And I didn't really know any R Markdown or Shiny before developing this, but luckily, thanks to Marcus, he put all of his code for his the TBEP's Seagrass transect dashboard on their GitHub page, and I basically just took that and used it as a skeleton for the county's dashboard, and just basically put in our stuff and worked from there. So that has been a really huge help. This would have taken much longer had I not had access to resources like that. So in just overall, there's been a pretty big improvement in productivity. Hoping to get this going a little faster. But I mean, we've had improvements in processing time. It's just less chance for human error, which increases our data reliability and also increases our ability to output trends and other data products like the dashboard. And you can see this difference in time. It's really rough. It really depends on the number of errors that are in our data set, staff availability. Sometimes we go to conferences, have meetings, so things like, especially the QA/QC, might take shorter or longer for any given period, depending on what staff have going on. But for the bottle kit request, at least 8 hours down to 5 minutes is, that's pretty accurate because it's basically just one click now and it just does it automatically. But, the rest, it's, this might fluctuate, but I think that it's a pretty good representation of what these open science tools have been able to do for our program in terms of productivity, which also gives our staff more time to focus on other projects. So we have so much data available that just haven't had time to really look into in terms of research. So we're hoping once we can get the QA/QC fully automated, then we'll have more time to focus on other projects like that. And so going forward, if you go to the dashboard, you'll see a link to our GitHub page, which doesn't have any repositories in it right now. The water quality dashboard is privated until I'm it's fully public and out there. But once that's opened, it'll have the code for the dashboard, our full data set, GIS files, and our water quality standards. So I started this GitHub page because I wanted it to be as open and transparent as possible. I think it's really good to get all this stuff out there and just easily accessible for the public if they're interested in that. And hopefully going forward, we can add more different types of data that we have to this. Like we have a lot of red tide and seagrass and benthic survey data. We do lake vegetation and stream condition index, which we have a lot of data for. So it would be really great to continue to make these public facing applications and just get them out there for people to see and use. And then hopefully at some point, I'm hoping to get our QA/QC code, or at least some snippets of it, on our GitHub, just to assist other people if they find that it's useful in processing their workflows. And with that, I will take any questions.
This is really amazing work, Alex. I could say that you've fully joined the open science cult and drank the Kool-Aid, so I'm super proud of you for doing that. Yeah, I have some questions, but I want to make sure that other folks have a chance to ask questions first. Lindsay, looks like you have a question.
Yeah, hey Alex, I just wanted to ask if you utilize the ArcGIS API when you are coding the web pages for public facing applications.
I have not used that. I've heard about it, and we've been kind of working with some other people in our group to get to the point to use that. I really would like to use that just to see what it is, but I haven't used it yet.
Cool, thanks. Yeah, a lot of HTML coding, if you remember that from MySpace and things like that. So it's pretty interesting though.
So my question for you, Alex, I think it's really fantastic that you've seemed to increased efficiencies of these processes like tenfold pretty much, which is amazing. And I think one of the great values of using these types of tools. And it sounds like it saved you personally a lot of time in your own job. But I'm curious, I know some folks actually are on the call from Pinellas County, but how have your colleagues received these tools? Well, how do they feel about it? Like, one could argue that, you're, I don't want to say taking away people's jobs, but in a sense, you're making processes that were maybe done by hand now automated. And so sometimes that comes with a bit of hesitation by others for wanting to adopt the tools. But I'm just curious, in your experience, have folks been receptive to this? Have they wanted to learn the tools? And what has that been like for you?
For sure. I've definitely heard some reservations, or some people have been nervous a little bit about taking away certain workloads, or taking some jobs. But I think for the vast majority of it, it's been really positive. I don't think I was really hired specifically for automation, but once I kind of demonstrated its usefulness and its ability to do things a lot faster, it was kind of like, okay, let's apply this to as much of our program as possible, and kind of just get the ball rolling on it. But no, everybody has been really excited for it. I think every time I demonstrate something at one of our meetings, it's kind of like, okay, this is pretty awesome. But yeah, I think just having that leadership support has been a huge help. It's been really supportive overall.
So yeah, so the leadership at Pinellas County, they've given you space and time to learn and develop the tools, it sounds like.
Absolutely. Yeah, it's been yeah, basically they'll just, hand something and say, can you get this, automated, and then just sort of let me deal with it until it's done. So it's been yeah, very, very open like that. It's been really great.
Yeah, it's really important for individuals that are in a leadership capacity that if they want to build the capacity of their team or colleagues to learn the tools and develop them, that space and time is actually made available for that. I say that all the time when I teach open science, that oftentimes I do have administrators or managers present in these trainings that can see the value of the tools, but because they're pulled in so many different directions, being in like a managerial role or capacity, that they don't personally have the time to learn them. So what they can do is hire somebody like Alex and give him the time and space to learn and develop the tools. And that's just making those resources available is just such an important part of bringing open science into an organization. And I'm just really impressed and happy that Pinellas County has done that. So that's why you're here talking to us today. Any other questions for Alex?
Hey guys, it's Emma. I just wanted to chime in quickly and say how appreciative I am of what Alex has done. I was doing probably 90% of that QA process before we started to do the data automation, and it has saved so much time, so many headaches. I mean, when I started with the county, we were doing everything by paper. And then we started to introduce the survey 123, and then we started to introduce the Hawk WIMS, and it's just tremendous to see how far we've come in just, the 5 years that I've been around Pinellas. So great job, Alex. We're really happy to have you here.
That's great. Thanks, Emma. Sounds like Nicole is also very appreciative too, Nicola Maloney. So you're getting all sorts of kudos from your colleagues. All right. Well, I think we should move on to Blake and make sure he has enough time. But again, thank you so much, Alex, for sharing all the wonderful work you're doing at Pinellas County. And I'm sure we'll talk soon in the future.
Okay.
All right. Blake, do I need to make you a presenter? Nope, you got it.
I think it should be good.
So I think I said earlier that Blake gave this training to us internally about 6 months, a year ago, something like that, and I thought it was really great. It's not specifically open science focused, but part of open science is communicating data and science and results and information, and so that's kind of what data visualization is all about. And so he's got some really good information that I wanted him to come share with you all today. So it's all yours, Blake.
Yeah, so just a bit of background. I was actually an artist before I was a scientist, and then eventually decided that it'd probably be more likely that I wouldn't go hungry if I chose the science route instead of the art route. And then, about halfway through graduate school, when I was contemplating, what am I doing with my life and all that fun stuff that you go through, realized, that I thought there was this sort of need for science communication to really sort of adopt more artistic types of principles and really thinking about, how do we create high impact figures that can effectively relay the messages that we want to both a scientific and a lay audience, and get people to actually look at these figures and God forbid even find them attractive or nice to look at. And so yeah, for the last several years, I work part-time as a graphic designer and working for different organizations and universities to help them improve their figures and their designs, infographics, those sorts of things. And this comes from, disclaimer, this comes from a 3-hour workshop that I run on data visualization. And it has like components where we would usually go into Illustrator or Photoshop and do some cool animations and things like that with figures. So today is going to be a very speedy, truncated version of this, but hopefully still gets all of the messages across to you. Warning, this is also very interactive, so you are all going to be expected to speak. So be prepared for that. No. But basically, the whole purpose of this is, realizing that a lot of times as scientists, it's easiest for us to, just kind of go with defaults, right? Just, create a quick graph using base R or going into Excel and just using the defaults that they give you and just putting something together. But really, when we think about what is the most impactful type of figure, it's one where you actually need to tailor it to your particular audience or to a particular message that you're trying to push. So realizing that, defaults are great templates, but you always want to build from them based off of the story that you're trying to tell and who you're trying to get that story to. And so here's an example of, if you just wanted to plot the functions of sine and cosine in R, this is, a very sort of simple base R type of thing. And they went a little even further by adding some colors. So they think they're probably doing a great job here. But how can we think about turning this template, this default, into something that's actually more appealing and gets the message across much more easily? And so this is an example of that. You can see there's a lot of added elements here. It's now very clear where our axes are, where true zero is. And here you can even sort of see, if I was just looking at this, I wouldn't have noticed that these endpoints here are actually at pi on either side. And so now they've been able to give us pi, which is more meaningful than, just this little point, 3.14, et cetera, type of thing. So it's just an example of how tailoring away from those templates can be much more effective for communicating whatever it is that you want to communicate. So today we'll talk about some tips and tricks to use to create high impact figures. Basically thinking about, the type of visualization that you choose is really important for conveying your message. We'll talk about ways that you can help emphasize your message to the audience to clarify that message so it's easier to understand, how to simplify your message so it doesn't have to be, you don't have to, do all the things and make it super complex. You can actually just pare things down so that it's easier for audience to understand what you're trying to say. And then last, a few other tricks to help present that message the most effectively that you can. So when we think about choosing the right visualization from the get-go, it's important to think about, the different purposes that different types of visualization serve. And so we've got something like a scatter plot here where it's just points, right? And so here we're really sort of saying this type of graph is really about the big picture and you're looking for just general relationships between one another. So we care as much about the difference between this point and this point as we do from that point and the point on the other end. So this is very big picture, just looking for sort of general observations across the entire space. Once we start adding lines to those points, now we are emphasizing the relationship between each of these individual points. And the fact that we still have points on them means that, there's something important about where these individual points are. If we remove those and just have a normal line graph, now all of a sudden the message isn't necessarily focused on how important each individual thing is, but rather the trend overall between points as they go. And then sort of similarly, scatter plot, adding that sort of trend line to that now draws the focus specifically to less about the big picture and creating sort of your own ideas, but explicitly telling you what it is that you want them to see from that big picture. And then bar graphs here, again, this is just using the exact same data, but bar graphs are useful for relaying quantities to people. So In this, because you can see just how dark the area under those bars are, people generally tend to associate bar graphs with quantities, so amounts of something. And that's where it's most useful to convey where we have more of something versus where we have less of something. And there's a million types of different visualizations that are out there. And this is just one of the little guides that I like that kind of tell you what type of visualization might be more useful for what you have. So whether you've got discrete categories of things that you're plotting, so you might do a little simple bar graph like that. If you've got kind of ordered character categories, or if you're doing some continuous metrics, and then what it is that you're plotting them with. So it's, one type of thing that you're looking at. You have multiple categories of things. If you've got hierarchies, all sorts of stuff. So this slide, all of these slides are online, so you can go through them on your own if you want to look at more, but it's fun to sort of look at it and say, oh, have you ever used a waterfall graph before? Maybe you actually should for the type of data that you have. Have you ever used a tree map before? So have fun exploring some of those just to see kind of what else is out there that maybe you aren't familiar with. Infographics are my favorite thing to work on. This is where you get sort of the most artistic freedom, and it's what the public tends to like the most as well, because your job for an infographic is to turn very sciencey types of communications into something that's more accessible and straightforward to an audience and cuts off a lot of the fat. So you just give the audience exactly what you want them to have. And you can, make it more interesting by having icons and symbols of things, even really complex things. Like here we talk about, and we had these are all papers that I've published. This one is a very sciencey ecological one where we're looking at, future predictions of Holdridge life zone shifts, and it's three-dimensional, types of things. And so very complicated, but we really sort of pare it down into the bare bones, try to make it as accessible as possible, and just highlight the key results. So if you're only going to take away a few things, here's sort of a representation of what the world is going to look like in several years, the most impacted biomes from climate change, all sorts of stuff. And yeah, and you can also go through all of these. These are also on my Twitter account. I don't really use Twitter anymore for various reasons, but feel free to go to my Twitter or X anytime if you want to see all of the different infographics that I come up with for papers. And these are also really good to learn how to do because a lot of papers now are wanting people to do graphic abstracts. So these are really good to include as graphic abstracts. Animations can also be really effective, especially my personal favorite is to use animations for maps. So I did a lot of research back in the day of things like land use land cover change, and it was always annoying looking at, multiple panels showing, forest cover change. And it's so hard to go through each one of them individually to find out where things are being lost or gained. But creating an animation makes it so much easier for your audience to be able to track exactly what changes are happening where over time. And here's an example of, climate change where you could just have a bunch of line graphs, right? Just for all of these countries all in the same spot. But having something like this actually, I think, is more effective at creating an impactful message about how exactly terrible life is. And so whenever you are making this choice about what it is that you want to use, two sort of key things to think about. Who's the audience? If you're primarily interested in, scientists and people with expertise, you can do some more jargony types of figures and instead focus more on how do you make it more attractive? How do you make it so that someone in your field who may not necessarily know exactly what it is that you've done will still be able to understand your model, your data results, those sorts of things. If you are looking for more of a public audience on the other end of the spectrum, think about more how you can do sort of data storytelling. So things like infographics, animations will be much more effective whenever it comes to choosing which visualization you want. And then also think about what is the underlying message. So how can you choose the right visualization that will explicitly emphasize the message that you are wanting to tell with that figure? And so I'm just going to give you some examples here. Oh my God, I've already been talking for a long time. So we're going to have a little less interaction than normal. But basically, here's an example of a study that was looking at death rates and new cases for different types of cancers between men and women. And this is typically what we would publish, what you would see published in a paper that's doing this sorts of things. It's very simple, very, straightforward default type of graph. But here, it might be difficult to really determine what message they're really trying to get across. There's a bunch of different things going on here. What's really the key takeaway? And by just switching things up a little bit, you can actually emphasize your message more clearly to the audience. In this case, what they're really trying to get at is the discrepancy among different cancers for the number of deaths versus the number of new cases. So just by superimposing those two metrics on top of one another here, now it's much clearer for the reader to see, okay, breast cancer is a good example of how, you do have a large amount of deaths, but you actually are getting a huge volume of new cases relative to that death rate. Same thing with prostate cancer. Some people die from it, but we're getting tons more of new cases. Or if you look at something like liver cancer, regardless of gender, the death rate is almost exactly the same as the number of new cases. And so this is just an example of tweaks that you can do to make it more attractive and to help emphasize a particular message that you're trying to push. And I'll give you some more examples of figures that aren't perfect, but that do a good job of emphasizing their messages. Here we have a map of the Great Barrier Reef, and they wanted to emphasize the areas where corals are not doing so great. And they just use the simple principles of your stoplight graphic. Red is bad, green is good. So even if you have no idea what this is showing you, you look at this and instantly say, okay, far north Queensland is, probably screwed, and southeast Queensland is might be okay. Here's another example. This one, you don't actually have to read any of this to realize that they are focusing your attention on these top two countries, Poland and the United Kingdom. And so this is a study that look at death toll from the Beast for the East, whatever that is, I can't remember, for different countries. But instead of bogging you down into all of these different things you could be looking at, they are explicitly highlighting these top two countries that are standouts among the rest of the world. So again, emphasizing that message, making it immediately clear where to draw your eye and what to focus your attention to. And then I just always want to include Florence Nightingale in this. She is considered probably the biggest pioneer of data visualization in the world with this figure that she made looking at mortality from the war. And so you can just sort of see the way that this is, the absolute number of mortalities and how they change rapidly over time and how quickly they start once the war starts, but also what they're dying from. And so you can see here sort of the big battle period of the war where a lot of people were dying more from wounds and battles. But once the battles started to decline, they started to die from disease or other causes instead. So again, really sort of emphasizing the message that they want to get across on how those different death causes change over time in the war. And now let's say you've done a really good job of being able to see how you are going to emphasize your message. Well, now let's help make it as clear as possible to the reader. Here's an example where on the left here, are basically trying to say, this is your retinal surface of your eyeball. And they're saying that, hey, on the collicular surface of your eyeball, there's actually a big difference in sort of warped projection compared to your retinal surface. And so you can see this by the big jump between 2 to 5 to 10 until it gets down to something more reasonable. But, this requires a lot of thinking, right? And maybe you need to be experts or at least need to read the caption to understand what's going on. But just a simple tweak of something like this, now you really don't even have to know what they're talking about to see, oh, okay, the message here is look at this uniform sort of distribution of these tiles, and now look how warped it is in comparison. And that's the key message here, is just looking at on this surface how warped that projection begins until the very end when it starts to look more similar to the retinal surface. So again, how can you clarify your message so it's instantly understandable from folks? Here's an example where this is a paper that I did looking at different typologies of clearers in Australia. This is an example of what I would show in the actual paper itself, graphs, jargony types of model table results. But then whenever we go to communicate to an audience, we don't expect them to figure any of this out. Instead, we say, what's the most important thing? Here we have active clearers and inactive clearers. Those are the two extremes that I want to highlight. So I have them here. You can see where they're situated in the state of Queensland. And I pull out all the important stuff from that model results so you can see exactly what I want you to know about each of these two different types of farmers. And then simplifying your message. And so maybe you've done a good job of, emphasizing what it is that you want to say, and you've clarified exactly, what it is that you're saying. But sometimes you don't have to make it so complicated. In reality, you want to make it easier and more simple for people to be able to take your message away. So this is a good example of things we constantly see in the science literature, where people just throw all these kinds of things on here and they think it's all there. This is what I want you to see. I want you to see everything all at once. But it's really not helpful for anyone who would want to know what's happening here. And so you can actually just simplify things and just tease each of those individual observations out, so that if I'm interested in series 3, instead of being like, oh God, how do I track, this red thing amongst this noise, I can go here and see exactly what's happening in series 3 while still getting the added benefit of seeing this background, where it sits amongst the rest of the clutter. And they've also done a nice job of cleaning up, the axes and things like that. So sometimes you don't have to have the chaos and the mess and all of the colors and everything. You can simplify it so that it's actually much easier for you to get across the message to your reader. Some examples of these that I'll just go through quickly. For each of these here, really they're just highlighting exactly what it is that they want you to focus on to ignore all of the noise that comes with presenting your data. So here's an example where they ranked like the toughest sports by skill. And instead of having you try to figure out what every single dot is, they're saying, we want you to focus on where boxing fits. It's our #1 toughest sword skill. So here's where it is on endurance, speed, nerve, power, diversity, art, durability, blah, blah, blah. Same thing, another graph here showing NBA win contributors. Don't really care if you know anything about all of this here. Just know this is the background stuff, and here's the main things I want you to focus on. And they have colors representing something or other, whatever these positions mean. And then another example here, looking at performances between countries from one year to the next for the Eurovision contest. Again, a bunch of things going back and forth, but really, I just want you to focus on where our prior low-ranking countries went to the top and where our high-ranking countries eventually went towards the bottom the next year. So again, making it simple, even if you've got very noisy data and you are hell-bent on showing everything in there, simplify it so that the reader knows, what do I spend my time on in this figure? And then now, once you've been able to do that successfully, think about how you want to present your message and the importance of perceptions and manipulations. So this is an activity where I am going to ask for participation from folks. So here's an example of people where they have scaled a particular value or these circles according to different values. So here you have this circle represents 30. Scaled down to a ratio relevant to 20, to 15, and to 10. That's what they look like. Now, if I was to present you with these size of circles, what do you think these circle values represent? So somebody tell me what numerical value you think this circle would represent. Someone that's not Marcus, because he should know the answer to it. Anybody? I will wait.
30.
30? Okay, so we have a vote for 30. What do we think this might be then? This circle here.
I have no idea.
No idea.
15.
15, 12. Okay. What might this be then?
7.5.
7.5. Ooh, we're getting really detailed. And then this last one, what do we think?
Close to 3.
Close to 3. Okay. What if I told you that they represent the exact same numbers and the exact same ratio of things? The difference is that this top one is being scaled by area, and this one is being scaled by the radius. And so this is important because if you look at these different strings of circles, you might say there is a much bigger difference between circles in this one compared to this one, when in reality, they're showing you they're represented by the exact same difference. And so if you want your audience to think that there is a big change between your values, you might want to choose to scale them according to radius. Otherwise, they might not see as big of a difference. Here's another example where if you look at this graph, it looks pretty uniform, right? It doesn't look like there's much variation going on. But what if I showed you a graph like this? Do you think that there's more variation in this graph than the other one? Yes, no, what do we think?
It depends on the on if it's like a 0 to whatever the values are, or if it's truncated data.
Look at that. So exactly. So we can change people's perceptions by showing them exactly the same data, but manipulating exactly how we display that information. So if you think about, a message that you're wanting to emphasize, if you show your data on a nice 0 to 100 scale, your audience, even though you might think this difference of 5 or 10 is meaningfully large, your audience may look at this and be like, oh, there's no difference. Okay, on to the next thing. I'm not one of those people who is a purist about you always have to start at 0. As long as you tell your reader exactly where you're starting from, and as long as you're transparent about it, I think it's fine. So, if you really want to emphasize that these differences are important, consider truncating it so that that message is more clearly relayed to your audience.
Blake, one thing I see this all the time. This example where they truncated the y-axis. I see it all the time in the news and media, and I think they do that to make things appear more dramatic than they actually are. And one could argue that it's a bit of manipulation, as you said right there on the slide. And just I like people to be aware of that particular issue because people do that all the time to portray something that is larger than it actually might be in reality.
Thanks, Marcus. That's how I feel about it too. Also, I think like I've seen people use like both in like a presentation, so it kind of trips the viewer. And so I think like when you do this, you have to be very clear, like, hey, we're doing this just to emphasize that, so you're not looking like you're trying to manufacture something or like mix the versions of the graphs too in the same presentation.
Yep. So it's all about, transparency and, especially, if you're going to have figures side by side, not having one of them on a completely different axis if they're both actually measured on the same axis. So choosing from the outset, whether you're going to always truncate them and by the same amount, or if you're always going to have it, at the true scale. But yeah, exactly. Sort of, thinking about here, we are talking about psychology. We are thinking about people's interpretations of things. And so if you don't, if you produce, something like this, and then you're surprised why the public isn't concerned or why they don't think it's an issue, recognizing that, if you present it this way, you are more likely not going to get the public to understand why you are concerned. And so considering that, as long as you're transparent and clear to them, presenting something that is more likely to get your message across, and weigh that out as you want. But yeah, always be transparent about it. And then I'm just going to wrap up, I think, with just a few conversations about colors. So there are different types of color maps that you can use, and they have different purposes. I am going to just go quickly. When we got what we call a qualitative color map, this is for, kind of discrete categorical things. There's not too much of a difference as you go between one or another. You've got diverging colors, and those are good for when you have a specific midpoint of something. So you go from one color to another color, usually like a white or a gray or some kind of middle point that represents a middle. And then you have more color on the end that increases the amount of difference. But if you want to use a sequential color map, that's usually for more continuous types of data. So there's not clearly like a midpoint or something to split your data into two or more sections, but really it's just a continuous gradient of just color or no color. And then, we're always wanting to try to be cognizant of color blindness. And so there's a lot of different tools out there to help you make colorblind friendly palettes. I have a collection of palettes that I really like, and so I use those. Classic and Trustworthy is what you saw on one of my previous figures. That's one of my favorites, but there's always ways to get around color blindness. Instead of using red, use vermilion. Instead of using green, true green, using bluish green, those sorts of things, just little bitty tweaks that make it so much easier for colorblind folks to see what you've got. And so last, I'm just going to do, we're going to do some taste testing, and I'll put up some figures and we can talk about what we like, what we don't like about them, now that we kind of have an idea of the types of things we're looking for in good figures. And so I'll try to go through them really quickly because I see we only have 7 minutes. But I'll just throw them up here and you all let me know generally what you think about some of these. So here we've got a scatter plot showing how the different UK constituencies voted according for Brexit. We've got a bar graph here showing the dates of the oldest national parks in the US, a timeline here of life expectancy at birth over time, and a few other sort of things. But yeah, I don't know. Folks want to say, what are there things you like on here or things you don't like on here? Why? Anybody?
The bar graph with the dates in the middle. Usually you think of time on the axis and some, quantity on the y-axis. So that just appears a little strange.
Yeah, so this is a good example of choosing the right visualization, right? Bar graphs are typically for quantities of something, but 1872, 1890, those aren't quantities of anything. Those are time. And so a line graph, would be more appropriate here, and especially because they are interpreting an older date to be a higher graph, even though that's 1872 versus 1890. So it's got all kinds of problems. So this does come from a particular park somewhere. So no shade to them if anybody knows who this park is. Any other comments or thoughts that people have about the figures here? Any of them?
The top right one, I've seen that style pop up more and more recently, particularly with climate change graphics. You can show temperature over, 100 years and just see the world getting hotter.
Yeah, so this is sort of a more creative approach to those sorts of kind of timeline-based things. And so I like them in terms of their creativity and what they are trying to do. But really a lot of people find these very confusing in sort of, being able to really track, can you actually tell how big of an increase it is from each of these times, and why are we looking at time as a circle? We think of time linearly, all sorts of things. But just in general, especially, this is an example from a paper that was published in Nature. These are all garbage. Please don't do them, and look at them as things to not do or to avoid. And then we have some other figures here. And just for the sake of time, I'm just going to say, like, there's some really good things that are happening in these. None of them are perfect by any means, but they show that, the the researchers are trying. So you've got some decent colors here representing, the different continents, and they're scaled by the size of population. And they are, trying to emphasize good and bad, right? So at the bottom here in red, you've got your extreme risk from climate change vulnerability. Up here, your stoplight graphic green is low risk. And so this is them trying to emphasize their message and make it visually appealing. You've got this person that was talking about land sparing versus land sharing, and sort of, how, what kind of ratio it tends to work. It tends to be more represented in reserves, open access areas, or pure sharing or managed landscapes. Then you've got these folks here doing stuff on deforestation in Queensland. And so they're showing, clearing rates by this green color in the background, but also saying, relatively of how much of the vegetation that's being cleared, is it least concern, of concern, or endangered? So you can add some more kind of context here. So none of these are particularly perfect. I all have problems with all of them, but we're getting into a better place. And then the last thing I want to do is just wrap up with some examples of how I would transform some figures. So here we're looking at, the proportion of births that happen at specific times of the day over the week. Instead of looking at this and being like, what am I supposed to look at? Instead, pick your key message. And so in this case, the key message is that weekend deliveries are much more common in the early morning. And so just doing this, keeping things the same color except for the main thing that you want them to focus on is really helpful for clarifying and simplifying the message that you want to get across. If you think of sort of, here's a graph showing the percent of the population in the Caribbean that was free or enslaved at a particular time. Again, simplify it. You can rotate the graph so you don't have all of your words crunching together. So they're nice and uniform. Yeah, keeping colors very simple, monotone, and highlighting this overall one if you want that to be sort of the key message here. This is another example of one that we saw similar, where instead of putting everything together, simplify it, tease it all out. You can still have all of the background context that you want, but now it's much easier for me to track what's happening for each one of these, what is it, delta over lambda or something or other. Here's another one where just a simple switch can make it much easier for the audience to see what it is that you want them to focus on, and also how to sort of more correctly bin relevant comparisons. Another example, keeping it simple, rotating so you don't have all this crunchiness, making the colors stand out even more, and also sorting things in order. So instead of our eyeball having to go up and down and then being like, where does this fit? Okay, there's 1, 2, 3, 4, however many above, you see exactly where they all stand in a nice, easy line. This map, it's showing continuous data, but they have decided to bin it. That's more work for your audience. Instead, if you've got continuous data, just make it a continuous color map. So we don't have to do all the work of figuring out what those bins mean. And then last, you don't really have to reinvent any wheels. It's nice that they wanted to take this creative approach to a traditional pie graph. But at the end of the day, it's much easier to see exactly what all of these percentages are, what it all means, and how they stack up to one another if you just do a simple type of bar graph like this. So you don't always have to get crazy creative and reinvent the wheel. And yeah, so that's me going through it very quickly. Hopefully you've learned something. There's lots of resources here and other things that I didn't get to, but are still in the slide deck if you want to look at more resources and tools for data visualization. But yeah. Okay. Oh my God, I think I made it.
Yeah, good job. That was what, a 3-hour workshop in 30 minutes? It's amazing. Yeah, so if you would like, I'm putting him on the stand here. If you would like Blake to come to your place of employment and give the full workshop, that may or may not be arranged. We'll see. But yeah, that's super great overview. Obviously, a lot more to understand and go through. The slides for Blake's presentation are in the shared Google Drive space, as well as Alex's, and a link to the agenda with a link to the updates I gave earlier during the meeting. So definitely check those out if you want to spend a little more time with any of the presentations. Key dates coming up, the next meeting for the Technical Advisory Committee is going to be June 26th. I believe we have actually the agenda is filled out for that right now. One particular presentation that may be of interest is a presentation by somebody we're working with to develop climate change indicators. So there's going to be sort of a status update on what those indicators are starting to look like, and we would love your feedback on whether or not they're useful or conveying the right information and all that. Next open science meeting is November 27th. Is that right? Yes, November 27th, second one of the year. I will announce or you'll see a poll for the co-chair nominations soon once I get those into my email inbox. So like I said at the beginning, if you have somebody you'd like to nominate or you want to nominate yourself, send me an email. If I don't get any nominations, I'm going to volunteer people. So hopefully I don't have to do that. But let me know. And then the hackathon is January 27th. So get that on your calendars and look for the formal invitation for that in the fall. So thank you all for a great meeting. Appreciate you all staying online a few minutes over, and we'll see you next time.
Thank you. Can I say something real quick?
Oh yeah, go ahead.
Yeah, so I'm part of the Florida Lake Management Society's board, and we're always looking for folks to present at our workshops and our talks. So these are all fantastic talks, and if anyone's interested in teaching a workshop or presenting, let me know.
Yeah, whatever the topic would be of interest to the group, I'd be happy to share something, maybe Blake or Alex as well. But yeah, we could talk offline, Issa, and maybe figure something out.
Good deal. Thanks.
All right, thank you. And the last minute comments? All right, thanks everybody. We'll see you next time.